Dear Raoul and John, could you answer this question from Peter J. Carroll? How can European countries reduce reliance on Chinese rare earths?
Technologies for wind and solar, or if there are technologies for nuclear energy, or to drive our digital transition. So when we look increasingly into AI, but also in defense, weapon systems, advanced radar. You look at the periodic table, you see things like lithium or nickel or cobalt, maybe you've heard of those, but rare earth elements, neodymium or dysprosium, these are new minerals for many folks, but they are crucial for the development of these technologies. So that's one element of criticality. The other is where these minerals are sourced from and how they are supplied. A defining characteristic of rare earths are, in fact, that they're not all that rare. You can find them scattered all across the globe. The problem is finding sufficient concentrations of those rare earths in a deposit that is economically exploitable and that is easy enough to pull out of the ground and then to extract and to process. The 20 most critical minerals for the digital transition, as well as for the energy transition. China dominates, on average, about 70% of the processing. But for some materials in particular, for rare earth elements, particularly what we call heavy rare earth elements, so dysprosium, that go into a magnet, China produces over 90, almost 95% of the processed dysprosium, processed heavy rare earths in the world today. China has been able to dominate the supply chain of battery raw materials, not necessarily in the extraction of these raw materials themselves, but in the processing of those raw materials. And so China's dominance is really along that whole supply chain.
After that, really a lot of mining enterprises also got state support and subsidies to actually go abroad to explore mines over there. Actually, they started operating from a very backward position, so they really needed to catch up to Western countries who had a long history of mining. And a lot of these mining industries, they were not very profitable. They started looking for specific techniques to actually extract different kinds of critical raw materials, minerals that we now need for the energy transition and for electric vehicles and everything. They gained a head start over the years because they were on this so many years before we were, in that sense. They seek to decrease this dependency by 2030 till about 65%. But that means quite a lot needs to be done in terms of diversifying partnerships with other countries. That is a huge task. The building of mines, so the lead time for building mines is actually increasing significantly over time. To go from not having a mine to actually mining, it now takes about 18 years. If you're talking about new mines, a problem is that many of the mines are of the most profitable mines. They have already been found. So you both need to explore, but then also it takes a long time to get permits, to go through the environmental regulations. All these, so there's a lot of red tape for opening up mines, and especially within the European Union, there's a lot of criticism of opening mines or reopening mines because they're polluting industries, and there is usually a lot of local protests for mining. Companies are continuously thinking about how to do similar things with different critical raw materials, also because the supply can be so challenging. So, for instance, for battery making, you might need lithium now, but in the future, you might no longer need it. So what happens if that is the case? There might be future technologies that might exclude certain critical raw materials. So you really need to connect future industries to your needs in the future as well. And that is a big challenge.